For acids and bases, we're going to look at the basics first before we look at any reactions. And to start, we need to define an acid and a base. And you have your definitions in the SAGs. That is, an acid is defined as a proton donor. Now, please remember, it's actually a hydrogen. And when we look at the three strong acids that you need to know, hydrochloric acid, sulfuric acid, and nitric acid, you'll see that they each have a hydrogen available. And if you look at the hydrogen atom, it had a positive nucleus, which is the one proton, and the negative electron. And if I take that electron away, I am only left with a proton. And that's why we can say a proton donor. So an acid is therefore defined as a proton donor. The next important thing is that you will see for acids, they talk about the ionization. A strong acid ionizes completely, and a weak acid only partially ionize. Now, what do they mean by ionize? And we have to quickly look at the reaction here to understand that. If you look at ionization, it is a substance that doesn't have ions already. So you'll see it says a molecular substance. So it's something that formed by covalent bonding, a sharing of electrons. So it's two nonmetals. When you show the ionization, you have to physically write plus H2O. So water forms part of the reaction. And the acid, as per the definition, will donate its hydrogen to the water molecule, forming an H3O plus ion. And what would be left here would just be our Cl minus ion. So now we have formed two ions that were not there originally. So I've made new ions, and that is then ionization from a covalent substance. Now, then the next thing that they speak about is the complete ionization of a strong acid and partial ionization of a weak acid. Now, if you look at the diagram here, you can see that if I start off with my acid molecule, which could be HCl if it was the strong one, what happens is all my Cl minus ions are these little red ones. There are none of them still as a molecule connected to each other. They're all going to be free ions here. And all my H ions have combined with a water molecule and forms this, we should say, a hydronium ion, not really a hydrogen ion. You'll see lots of textbooks simplifies it, but it's actually now the hydrogen that is connected to my water molecule, which forms the H3O plus ions for the strong acid. So when I write this reaction, I'm going to write a one-way arrow because all my HCl's have connected or reacted with H2O to form the ions. But if I look at a weak acid, for instance, HF, what happens now is that some of the HF molecules will still be intact. You can see here in the particle diagram, and be careful in a multiple choice question, look out for that. They are still intact, and some of them have ionized. And when I write this reaction, I would write HF plus H2O exactly the same as for the HCl. But I can form F minus ions with my H3O plus ions. But remember that there can be some of these as well. And therefore, I need to write a double arrow for the weak acids where I write a single arrow for the strong acids. Now, moving on. And this will be the same for bases as well, for strong bases and weak bases. We'll just use a little bit of a different word there, but just remember for particle diagrams, it will look the same. Now, for polyprotic acid, what you need to remember is a polyprotic acid just means that it has more than one hydrogen that it can give us. Polyprotic is anything more than one. But when you have two hydrogens, it will be diprotic. When you have three hydrogens, it will be triprotic. One would be monoprotic. And you already have examples of these because you know H2SO4 will then be a diprotic acid. We can use H3PO4 as a triprotic acid. And then just remember that this one would be strong. So when it ionizes, you'll write a single arrow, and this one will be weak. And so you'll write a double arrow. For our purposes, it's only the 3 strong acids that we're going to look at. All the others are considered weak, and these are the ones you need to know. It's the hydrofluoric acid, phosphoric acid, sulfuric acid, and then all the organic acids will be seen as weak acids. They might give you an acid that you've never seen and tell you on the basis of ionization or the Ka values, which we'll look at now, whether the acid is strong or not. So just read your questions very carefully. If you look at the ionization, here they tell you single arrows for the strong acids and double arrows for the weak acids. That is important for our IEB exam. When they talk about the diprotic and triprotic acid, when you do the reaction, sometimes you're going to write it as one step like you see here, but you could be asked to write it as to more reactions. Then you'll just give us one H3O plus first to give me the HSO4 and HSO4, and then we're going to move on and do it again. But we'll look at this now when we look at the ampholytes. We're going to look at that again. Now, just quickly looking at what is a concentrated and a dilute acid. Concentrated only means that there's a lot of acid compared to the water. It's the water-acid ratio, and that is it. This is still a strong acid because you can see that it ionized completely. If you look at this one, it's still ionized completely, so it's still a strong acid. But because the ratio of acid to water is smaller, now we're going to call this a dilute acid. So just make sure that you know the difference between a concentrated and a dilute acid. Now, if we look at bases, you're going to see in the definition of a strong base that they're going to be talking about dissociation and not ionization. And strong bases are seen as the bases in the group 1 hydroxide. So it will be NaOH, KOH, and so on. And you know that it's an ionic substance because it's a metal and non-metal combined. So now this time I don't have to write H2O. You can write H2O on top of the arrow if you want, but another way of showing that it was in water, you can just give me the ion Na plus OH minus, and then you're just going to give me that it's AQ, because then everyone knows that it's in solution and we don't have to worry about it anymore. So all it is that the ionic substance has split up into the 2 ions that it was made of originally. Now, a strong base will be seen again as a base that dissociates completely. So you will get your single arrow again, where if I look at a weak base and you are lucky, you only have to consider group 1 hydroxides as strong, and all the others will be seen as weak bases. Group 1 hydroxides will be the strong bases, except if the question again gives you a hint. Now let's quickly talk about the Ka and the Kb value, because if it ionizes completely, it means that I have a lot of product compared to reactants. And if you remember back to the equilibrium chapter, Kc or Ka or Kb will be the concentration of my products over the concentration of my reactants. So if I have a lot of products, then my value will be very big. So for a strong acid and a strong base, my Ka and Kb values will be big. Also, there are many ions swimming around in the solution, and therefore it will be able to conduct electricity better. So if it's a better conductor of electricity, it will be a stronger acid or a base. And if it's it has a higher Ka or Kb value as well. Now, again, for the bases, you're going to write a single arrow for the dissociation of a strong base. And then for the weak base, now here is where we have a problem because it says dissociate or ionize. Now, why do they say ionize here? So you will see that all bases don't have OHs. A base is defined as something that will accept a proton, so it doesn't have to be something with an OH. The common one that you get is ammonia. So NH3, that's not an ionic substance. You can see that it's a molecular substance because, again, it's a non-metal, non-metal. So when you write out the reaction for ammonia, you have to again write plus H2O because there were no ions that can split up. And we are going to look at what the base must do. A base is a proton acceptor. So the base will accept the proton, meaning that there's now an extra hydrogen, and you know this ion is ammonium. So it's my NH4 plus ion. And then what I've got left there is my OH minus. So the NH4 plus and the OH minus is sometimes also written as NH4OH, which is ammonium hydroxide. But just remember that it is just ammonia. And when ammonia ionizes in water, this is the typical reaction that you will see. And that is important for you to know. Metal carbonates, metal hydrogen carbonates, and all of those will be seen as weak bases that only partially dissociate in water, and you will therefore write a double arrow. Also, this one is seen as a weak base, and we will write a double arrow. The only place where we are going to write a single arrow would be for the group 1 hydroxides, which is then seen as the strong bases. Please know that, what did I want to say? Please again know that the Kb value will give you an indication of how strong the base is. So if the Kb value is very high, you know it's a strong base. And also if it's a good conductor of electricity, then you know it's a strong base. Exactly the same as what we did for the acids.